Resnick, Chapter 8, Problem 42. A worker pushed a 27-kilogram block 9.2 meters along a level floor at constant speed with a force directed 32 degrees below the horizontal. If the coefficient of kinetic friction between the block and floor was 0.2, what were A, the work done by the worker's force, and B, the increase in thermal energy of the block floor system? So we have a block and it's being pushed along the floor at 9.2 meters. That's the distance it's going to be pushed. And we know what we're going to have. F of K, that's friction, kinetic, in the opposite direction. We have (32 degrees below the horizon), and we have the normal force that we're going to have to compute. So this is our block diagram, so not our force diagram. For the normal force, N minus mg minus, this is the force, this is F cosine theta, and this is F sine theta. So we have minus F sine theta is equal MA. The block's not going to come up off the floor, so this is 0. This goes to N equals mg plus F sine theta. And we know that F of K is equal to mu N. So this will go to F of K is equal to mu times mg plus F sine theta. And we're going to be solving for the force. At this point, we have F cosine of theta is going to equal Fk. And we know that because the block is being pulled at a constant speed. It's not accelerating. So Fk is equal to F cosine theta. Fk is equal to F cosine theta because it's being pulled at a constant rate, which is going to equal mu. And we just may as well multiply this out. Mu mg plus mu F sine theta. Take this on the other side. We will have F cosine theta minus mu F sine theta is equal to mu mg. We can take F out of this. We'll have F times cosine theta minus mu sine theta is equal to mu mg. We're doing all this, we need the force. So we're doing this calculation just to pull the force out of these equations. And that's going to go to F equals mu mg over cosine theta minus mu sine theta. So F, we're going to plug in some values now, is equal to 0.2 times 27 kilograms times 9.8 divided by the cosine, and this is 32 degrees below the horizon, below the horizontal plane, 32 degrees minus 0.2 times, that's mu, 0.2, the sine of 32 degrees. And when we do the math, we see that it's going to equal 71.314 or 71.32 newtons. Now, if we want the work done, we're doing all this, finding the force, just so we can calculate the work. That's why we're going through all this. Work is equal to force times distance. And in this case, the force is 71.32 newtons times the 9.2 meters times the cosine, that's what this dot product, this dot is about, times the cosine of 32 degrees. So let's do that. 71.32 times 9.2 times the cosine of 32. And we get 5.56 times 10 to the minus 2 joules of work. Now, part B wants to know the increase in thermal energy of the block floor system. So B, part B, increase of thermal energy. Now, that'll just be the frictional force, which is mu Fn times the distance. So that'll be the increase in thermal energy. So we'll have thermal energy, E thermal, is going to equal 0.2 times, well, we got Fn here, which is, M is 27, times 9.8 meters per second squared, plus the frictional force that we figured out, which is 71.32, times sine 32 degrees, times 9.2 meters. And when you do that for the heat dissipated on the floor or thermal energy, you're going to get 556 joules, which is approximately equal to 5.56 times 10 to the minus 2 joules.